Hey guys! In this video, we're gonna find the volume using the dishwasher method and the cylindrical shell method. So what's the difference and how do we know which one to use? Well, don't worry, it's very easy. So let's start with the dishwasher method. Here we have a function y is equal to x to the power of 3, and we want to take the area between the y-axis and this function. So we want to take the area here and rotate it around the y-axis. So as you can see, this is the three-dimensional object that we want to find the volume of. So if the object looks like half of a cucumber, then you have to use the dishwasher method. And this method says that if the cross-section is on the y-axis, then you integrate with respect to y. If it's on the x-axis like this, then you have to integrate with respect to x. Since it's on the y-axis, the volume formula is going to be equal to the integral from a to b, where a is the bottom right here, and b is the very top, so b is right here, of a of y dy, where a of y is the area of the cross-section. Now, I'm going to show you an easy trick to remember this formula. All you have to do is understand it. So basically, this part is saying that we're going to find the area of the cross-sections from A to B. So starting from A, we're going to find the area of the cross-section here, and then we're going to find the area of the cross-section here, and then here, and then here, and I think you kind of get the idea. So we're going to keep finding the area of the cross-sections until we reach the very top, where d of y is the thickness of this dish. So it's like the thickness, the distance from here to here. That's going to be the thickness of the dish. And at the end of the day, the integral sign means that we're going to add all of the areas of the cross-sections from the top to the bottom. And that's going to give us the volume of this three-dimensional object. Let's go ahead and find the volume. So step number one, we want to find A and B. So since A is right here at the center, then A is equal to 0, where B is equal to 8. So I wrote the number 8 right there. So B is going to be equal to 8. Step number two is to find the area of the cross-section. So since the cross-section or the dish is a circle, then the area must be pi times the radius to the power of 2. So the area, A of y, is equal to pi times the radius to the power of 2. Now the distance from the center until we reach the cross-section is y. And the distance from the y-axis until we touch this function, this distance is x. And so the radius is x. So the area is the same as pi times x to the power of 2. So since we're trying to integrate with respect to y, we need to rewrite this function in terms of y. Now we know that y is equal to x to the power of 3. So if we take the cube root of both sides, we're gonna get x is equal to y to the power of 1/3. And we can replace it with x right here. So finally, the area is equal to pi times y to the power of 1/3 to the power of 2. And that will simply give us pi times y to the power of 2/3. Now we found the area of the cross-section, we can go ahead and substitute it back into the integral. The third and final step is to evaluate this integral. So since pi is just a constant, we can move it outside of the integral. So v is equal to pi times the integral from 0 to 8 of y to the power of 2 over 3 dy. This is the same as pi times the antiderivative of y to the power of 2 over 3. So we're going to get y to the power of 5 over 3, and then we divide by 5 over 3. So when you divide by a fraction, it's the same thing as multiplying by its reciprocal. And then the limit goes from 8 to 0. So the next step is just substituting these numbers into our formula. We're going to get pi times 3 over 5 times 8 to the power of 5 over 3 minus 3 over 5 times 0 to the power of 5 over 3. So we know right away this right here is going to be 0. Now, what is 8 to the power of 5 over 3? Well, 8 to the power of 5 over 3 is the same as 8 to the power of 1 over 3 to the power of 5, which is the same as 2 to the power of 5, which is just 32. So pi times 32 times 3 is going to be 96 over 5, and the final answer is equal to 96 over 5 times pi. Now you can leave it the way it is, or you can say unit to the power of 3. Basically, that means we have found the volume of this three-dimensional shape using the dishwasher method. Now let's take a look at the second method to find the volume, which is the cylindrical shell method. So we have a function y is equal to 2 times x to the power of 2 minus x to the power of 3. And we're going to take the area between this function and the x-axis and rotate it around the y-axis. Before I show you how to find the volume, I would like you to pause the video and try finding the volume using the dishwasher method. And you will notice that it's impossible. The trick here is if the shape that you get does not look like a cucumber cut in half. So in this case, our three-dimensional object looks kind of like a mountain with a dent inside it, and it does not look like a cucumber shape cut in half. You have to use the cylindrical shell method. And the shell method says that if we have a cylinder, if we put the cylinder here, and the base of that cylinder is on the x-axis, then you integrate with respect to x. If the base of the cylinder is on the y-axis, so if the cylinder looks like this, and the base of the cylinder is on the y-axis, then we integrate with respect to y. In this case, it's on the x-axis, so the volume formula will simply be the integral from a to b of 2 times pi times the radius times the height. D of x is just the thickness of the shell. So it's basically the distance from here to here. That's going to be the thickness of the shell right there. So what this formula is saying is from A to B, so from A right here, and B, this is A and that's B, we're gonna take the volume of each shell. So we're gonna take the volume of this shell right there, and then we're gonna take the volume of this shell moving from here to here, right? So the volume of this shell, and then we're gonna take the volume of this shell right here, and then as we move towards B, we're gonna take the volume of this shell right there, and then we're gonna take the volume of this shell. So I think you understand what I mean. And then finally, we're just gonna take the volume of the final shell, so this shell right there. And the integral sign right here means that we add all of those volumes of our shells together, and that's gonna give us the volume of our three-dimensional object. Now, let's find the volume of this shape using the formula. So step number 1 is to find A and B. So A is gonna be in the middle. So A is at the center, and therefore A is equal to 0, and B is right here, so B is equal to 2. So the integral goes from 0 to 2. The second step is to find the radius and the height. So looking at this shell, we know that the radius is just x from here to here. So the radius r of x is equal to x. Now, how about the height, f of x? The height is just y. So f of x is equal to y. And we know that y is equal to this right here. So that's going to be 2 times x to the power of 2 minus x to the power of 3. Step number 3, and the last step, is to evaluate this integral. So since 2 pi is just a constant, we can move it outside of the integral. So we're going to get 2 times pi times the integral from 0 to 2. And x times this, we're going to get 2 times x to the power of 3 minus x to the power of 4 dx. And this is the same as 2 times pi times the antiderivative of 2 times x to the power of 3. And if you find the antiderivative, you're going to get 1 over 2 times x to the power of 4 minus 1 over 5 times x to the power of 5. And the limit goes from 2 to 0. If you substitute these limits in, you're going to get 2 times pi times 1 over 2. And then when you put the 2 in here, you're going to get 16, because 2 to the power of 4 is 16. Minus 1 over 5. And when you put the 2 in, you're going to get 2 to the power of 5, which is just 32. And when you substitute the 0, everything else is going to be 0. So this is our substitution, and we finished it. And this is equal to 2 times pi times 1 over 2 times 16, which is 8, minus 32 over 5. Now, 8 is the same thing as 40 divided by 5. So this is 40 divided by 5. And then 40 over 5 minus 32 over 5 is the same thing as 8 over 5. So this is 8 over 5. And when you multiply these two together, the answer will simply be 16 divided by 5 times pi. And you can leave it the way it is, or you can say unit to the power of 3. So there we go. This is the volume of our three-dimensional object using the cylindrical shell. In this video, we're gonna find the volume using the cylindrical shell method. So let's say we have a function y is equal to x times x minus 1 to the power of 2. That's this pink function right here. And we're gonna take the area between 0 and 1, so it's this area right here, and we're gonna rotate it around the y-axis. So once we do that, we're gonna have this three-dimensional object that we want to find the volume of. So we wanna use the shell method when our three-dimensional object looks like a mountain with a dent inside it. And the shell method says that if we place a cylinder like this, and the base of the cylinder is on the x-axis, then we integrate with respect to x. If it's on the y-axis, so let's say we have a cylinder, and the base is on the y-axis, kind of like this, then we integrate with respect to y. Now, in this case, it's on the x-axis. So the volume formula will be v is equal to the integral from a to b of 2 times pi times the radius times the height, which is f of x. And then don't forget the d of x right here. Step number 1. We want to find a and b. So a will always be the start, which is in the middle, and b is at the end. And so a is equal to 0, and b is equal to 1. The second step is to find the radius and the height. So the radius is basically the distance between here and here. and we can say that this distance is x. And then the height is the distance from here to here, and we can say that this distance is y. So the radius, r of x, is the same as x. And then the height, which is f of x, is equal to y. Now, since we're integrating with respect to x, we need to rewrite this function in terms of x right there. So how can we do that? Well, we know that y is equal to x times x minus 1 to the power of 2. So we can simply say that y is equal to x times x minus 1 to the power of 2. So the next thing that we should do is substitute these formulas back into our formula right here. So the radius is simply x, and the height, which is f of x, is x times x minus 1 to the power of 2 times dx. The last step is to evaluate this integral, and that will basically give you the volume of this three-dimensional object. So since 2, pi are constants, they're just numbers, we can bring them outside of the integral. So v, the volume, is equal to 2 times pi times the integral from 0 to 1 times x times x times x minus 1 to the power of 2 dx. I know it's a handful. So we're gonna have 2 times pi times the integral from 0 to 1 times x again, and in here this is gonna be x to the power of 2 minus 2x plus 1 dx. So we can also rewrite this as 2 times pi times the integral from 0 to 1 times x times, we're gonna multiply x by these expressions right here. So we're gonna end up with x to the power of 3 minus 2 times x to the power of 2 plus x. And then we close the bracket and we have dx. Then we're also gonna have 2 times pi times the integral from 0 to 1. And this is gonna be x to the power of 4 minus 2 times x to the power of 3 plus x to the power of 2 dx. So this is equal to 2 times pi times the antiderivative of x to the power of 4. So we're going to have x to the power of 5, and then we divide by that exponent, so we have 1 over 5, minus the antiderivative of 2x to the power of 3. So we're going to have 2 times x to the power of 4, so we add the exponent by 1, and we divide by that exponent, so divide by 4. And at the end of the day, we're just going to have 1 over 2 times x to the power of 4. And the antiderivative of x to the power of 2 is simply 1 over 3 times x to the power of 3. And the limit goes from 0 to 1. So the top is 1, the bottom is 0. And the thing that we need to do is we need to substitute these numbers into our formula right here. So we're going to get 2 times pi times 1 over 5 times 1 to the power of 5 minus 1 over 2 times 1 to the power of 4 plus 1 over 3 times 1 to the power of 3. And we need to minus the lower limit. So we're going to substitute 0 in here. We're going to get 1 over 5 times 0 to the power of 5 minus 1 over 2 times 0 to the power of 4 plus 1 over 3 times 0 to the power of 3, and we can close the bracket right here. Now, if you pay attention, you will know that this whole thing is going to be 0. So that's the first thing that we can do, is to simplify it. So this right here is going to be 0. And then 1 over 5 times 1 is going to be 1 over 5. 1 over 2 times 1 to the power of 4 is just going to be 1 over 2. And the same thing here, that's just going to be 1 over 3. So we're going to get 2 times pi times 1 over 5 minus 1 over 2 plus 1 over 3. The common denominator is going to be 30, so we get 2 times pi times 6 over 30 minus 15 over 30 plus 10 over 30. Now, 6 minus 15 is negative 9, and negative 9 plus 10 is positive 1. So this is equal to 2 times pi times 1 over 30. And this is the same as pi divided by 15. So this number right here is the volume of our three-dimensional object. Let's do one more problem. So we have a function y is equal to x minus x to the power of 2. And that's what the function looks like. It's a parabola. And we're going to rotate the area between 0 and 1, so this area, and we rotate it around x is equal to 2. So once we do that, we're going to get this three-dimensional object. If we place the cylinder right here, notice that the base of the cylinder is on the x-axis, so we integrate with respect to x. The formula will be v is equal to the integral from a to b of 2 times pi times the radius times the height dx. Now go ahead and try this problem and find a volume. And I'll show you the answer right now. So the first step is to find a and b. Our original function goes from 0 to 1. So a is 0 and b is 1. What is the radius? Well, if you look at the diagram, we know that the distance from here to here is 2. The distance from here to here is 2. The distance from the center until it touches our cylinder is x. So the radius is the distance in between. And we can find that distance by taking 2 minus x. So the radius will be equal to 2 minus x. And how about the height? The height will be just y. So f of x is the same as y. And y is equal to x minus x to the power of 2. Because that is our function right there. Now let's go ahead and substitute these back into our formula. What is 2 minus x times x minus x to the power of 2? Well, let's find that first. So we got 2 minus x times x minus x to the power of 2. So we're going to take this multiplied by this, then take this multiplied by this, and then the same thing for our second term. This will be equal to 2x minus 2x to the power of 2 minus x squared plus x to the power of 3. This is simply x to the power of 3 minus 3 times x to the power of 2 plus 2x. Since 2 pi are just constants, we should bring them outside of the integral. So this is equal to 2 times pi times the integral from 0 to 1 of x to the power of 3 minus 3 times x to the power of 2 plus 2x dx. Let's evaluate this integral. So this is equal to 2 times pi times the antiderivative of x to the power of 3. We're going to get 1 over 4 times x to the power of 4 minus the antiderivative of 3x to the power of 2. So we're going to get 3 times x to the power of 3. We add the exponent, then we divide by that exponent. So this will simply be x to the power of 3. How about the antiderivative of 2x? Well, we add the exponent, so we get 2. Then we divide by 2. And at the end of the day, we're just going to get x to the power of 2. Now the limit goes from 1 to 0. And we got to substitute these numbers into our formula. So if you substitute it, you will get 1 over 4 minus 1 plus 1. We know that this is going to be 0. So this will be equal to 2 times pi times 1 over 4. And the answer will be pi divided by 2. So you can leave it the way it is, or you can say unit to the power of 3. It's completely up to you. But this number right here is the volume of our 3-dimensional object. How about this problem? So we have a similar problem. This time we have y is equal to 4x minus x to the power of 2. So it's a parabola right here. And what we're going to do is we're going to rotate the area between 0 and 4 around x is equal to negative 2. So once we rotate it around this axis, we're going to have this 3-dimensional object. And because we place the cylinder here, and the base of the cylinder is on the x-axis, we integrate with respect to x. So the volume will be the integral from a to b of 2 times pi times the radius, which is r of x, and then times the height, which is f of x. And don't forget the d of x right here. The first step is to find a and b. If you take a look at the original function, it goes from 0 to 4. So a is 0 and b is 4. Step number 2 is to find the radius and the height. So if we place the shell right here, the radius is the distance right there. So we know that the distance from the center until we reach the outer shell is x. And we also know the distance from the center until the axis is 2. So the radius is just 2 plus x. Now let me write that down. The radius is equal to 2 plus x. Now how about the height? F of x? The height is just y. So this is going to be y. And we also know that y is equal to 4x minus x to the power of 2. Now let's go ahead and substitute it into our formula. What is 2 plus x times 4x minus x to the power of 2? Well, let's write that out. We got 2 plus x times 4x minus x to the power of 2. This is the same as 8x minus 2 times x to the power of 2 plus 4x to the power of 2 minus x to the power of 3. This will simply be negative x to the power of 3 plus 2 times x to the power of 2 plus 8x. Now let's substitute this back into the formula. Since 2 pi are just constants, we should move them outside of the integral. So we're going to get 2 times pi times the integral from 0 to 4 of negative x to the power of 3 plus 2x to the power of 2 plus 8x dx. This will be the same as 2 times pi times the antiderivative of negative x to the power of 3, which is just negative 1 over 4 x to the power of 4, plus the antiderivative of 2x squared, which is just 2 over 3 times x to the power of 3, and the antiderivative of 8x. So that's going to give us 4 times x to the power of 2, and the boundary goes from 4 to 0. And let's substitute all of them in. So we're going to get 2 times pi times negative 1 over 4 times 4 to the power of 4 plus 2 over 3 times 4 to the power of 3 plus 4 times 4 to the power of 2. And if you substitute a 0 in, it's just going to be 0 at the end of the day. So this is just going to be minus 0. And we can close the bracket right there. Let's rewrite this as 2 times pi times negative 1 over 4. And 4 to the power of 4 is going to be 256. So 256 plus 2 over 3 times 4 to the power of 3 is 64. Plus 4 times 4 to the power of 2 is just going to be 16. This is the same as 2 times pi times negative 256 over 4 plus 128 over 3 plus 64. 256 divided by 4 is the same as 64. So this is going to be 64. And negative 64 plus 64 is just 0. So we're going to have 2 times pi times 128 divided by 3. This is the same as 256 divided by 3 pi, unit to the power of 3. So this right here is the volume of our 3-dimensional object. In this video, we're going to find the volume using the cylindrical shell method, but we're going to do examples where we have to integrate with respect to y. So let's take a look at this example. We have a function, y is equal to x to the power of 3 over 2. That's this pink function right here. And we're going to take the area between 0 and 8, so this area right here, and rotate it around the x-axis. So once we do that, we're going to have this 3-dimensional object that we want to find the volume of. The cylindrical shell method says that if we place a cylinder and the base of the cylinder is on the y-axis, then we integrate with respect to y. If the cylinder is on the x-axis, so let's say we place a cylinder and it's on the x-axis, then we integrate with respect to x. In this case, the base of the shell is on the y-axis, so we're going to integrate with respect to y, and the volume formula will be the integral from a to b of 2 times pi times the radius. Since we're integrating with respect to y, it is r of y, and the height of the shell, which is f of y, and do not forget the dy. The first step is to find a and b. So if you look at our original function, the bottom is 0, the top is 8. So it goes from 0 to 8. Because of that, a is 0 and b is 8. The second step is to find the radius and the height. So if you look at this, we know that the center, the distance from the center until we reach the outer shell, so this distance right there, is the radius. And the radius is just equal to y. So r of y is equal to y. Now, how about the height of the shell? The height is the distance from here to here. So the distance from the center until we reach the top is x. So the height is simply x. And we also know that we are integrating with respect to y, so we must rewrite x in terms of y. Now let me show you how to do that. Since y is equal to x to the power of 3 over 2, so we know that y is equal to x to the power of 3 over 2, then x must be equal to y to the power of 2 over 3. So for that reason, x is the same as y to the power of 2 over 3. Now, before I move on, I just want to explain very quickly how I got from here to here. So if you want to solve for x, all you have to do is just take the power of 2 over 3 on both sides, like this. And after you solve it, this is what you're going to get. So we found the formulas that we need, and let's go ahead and substitute them back into our integral. We know that the radius is just y, and then we also know that the height is going to be y to the power of 2 over 3. And do not forget the d of y. The last step is to evaluate this integral, and that will give you the volume of this three-dimensional object. So since 2 pi is just a constant, we can move it outside of the integral. So we're going to get 2 times pi times the integral from 0 to 8, and y times y to the power of 2 over 3. Now, let's review some exponent rules. If we have y to the power of a times y to the power of b, then the exponent rule says we're going to get y to the power of a plus b. So the power of here is 1. So 1 plus 2 over 3. So let's try that. We're going to get y to the power of 1 plus 2 over 3. And that's basically going to give us y to the power of 5 over 3. So this right here will be y to the power of 5 over 3 dy. This is equal to 2 times pi times the antiderivative of y to the power of 5 over 3. It's very easy. So you add the exponent by 1, you're going to get 8 over 3, and then you divide by that exponent. So when you divide by a fraction, it is the same as multiplying by its reciprocal. And the limit goes from a to 0. If you substitute these numbers into our formula, you're going to get 2 times pi times 3 over 8 times 8 to the power of 8 over 3 minus 3 over 8 times 0 to the power of 8 over 3. Now, this right here, this part right there, is just going to be 0. What is 8 to the power of 8 over 3? Well, let's find out together. 8 to the power of 8 over 3 is the same as 8 to the power of 1 over 3 to the power of 8, which is the same as 2 to the power of 8. 2 to the power of 8 is the same as 256. We can also simplify this fraction. So this is going to be 1, this is going to be 32. So this is going to be equal to 2 times pi times 32 times 3. That's going to be 96. Close up bracket. 96 times 2 gives you 192 times pi, unit to the power of 3. So this number right here represents the volume of our three-dimensional object. Let's do one last problem, and this one is a problem I did on a test before. So we have a function y is equal to the arcsine of x, so that's this arcsine function right here. And we're going to take the area between 0 and pi over 2, so the area right here, and rotate it around the line y is equal to 3. So once we do that, we're going to get this three-dimensional object that we want to find the volume of. When we place the cylinder right here, we know that the base of the cylinder is on the y-axis, and we will integrate with respect to y. So the volume formula will be v is equal to the integral from a to b of 2 times pi times r of y times f of y dy. The first step is to find a and b. If we take a look at our original function, we start from 0 and we go to pi over 2. So a is 0 and b will be pi over 2. The second step is to find the radius and the height. Now, the distance from the center until we reach the shell is always y. So that's the distance right here. The distance from here to here is 3, which means that this right here is the radius. That's the radius. And you can just find the radius by taking 3 minus y. Therefore, the radius will be equal to 3 minus y. How about the height? The height will be the distance from here to here. That's the distance of the height. And the height will simply be x in this case. Now here's the trick. Since y is the same as the arcsine of x, then this means x is equal to sine of y. It's just one of the rules that you need to know. Because of that, x is equal to the sine of y. Let's go ahead and put it back into our integral. The last step is to evaluate this integral. So since 2 pi are just constants, we should move them outside of the integral. So we have 2 pi times the integral from pi over 2, and at the bottom this will be 0, and we have 3 minus y times sine y and then dy. So what should we do here? Well, it's pretty simple. We're gonna take this, multiply by this, then take this, multiply by this. So we're gonna get 2 times pi times the integral from pi over 2. This is gonna be 0. This is gonna be 3 times sine of y minus y times sine of y dy. This is the same as 2 times pi times the integral from 0 to pi over 2 of 3 times sine of y dy minus the integral from 0 to 2, or rather pi over 2, of y sine of y dy. So all I'm doing here is I'm just separating these two terms into two different integrals. We are almost done. So the first thing we need to do is evaluate this integral right there. So we have pi over 2, and this is going to be 0, 3 times sine of y dy. So we can say that this is the same as 3 times the integral from 0 to 2 of sine of y dy, because 3 is just a constant. This is equal to 3 times the antiderivative of sine of y. And what's the antiderivative of sine of y? Well, that's going to be negative cos of y. And the boundary goes from pi over 2, and the bottom will be 0. So let's go ahead and substitute in these numbers. We're going to get 3 times negative cos of pi over 2 minus the lower boundary, which is negative cos of 0, and we close the bracket. Now, cos of 0 is just going to be 1, so this right here will be negative 1. And when you minus a negative number, it's the same thing as adding that number. So this is the same as plus 1. And for this one, you can just put in a calculator. This will give you 0. So this right here will be 0, and negative 0 plus 1 will simply be 1. So this is just 3. Let's go ahead and take this out. And this right here will simply be 3. Now, how about this integral right here? In order to solve that integral, we need to find its antiderivative first. So we have the antiderivative, which is the integral of y times sine of y times d of y. And we have to use integration by parts. So what's the formula for integration by parts? Well, it's u times dv is equal to u times v minus v times d of u. So there's an acronym that you can use in your textbook, hopefully, which is LIATE. I don't know if that's how you pronounce it, but this is LIATE, where L stands for log, I stands for inverse trig, A stands for algebra, T stands for trig, E stands for exponent. And if you look at this, we know that Y is the algebra, T is the sign. So whatever comes first is U, whatever comes second is V. That's the way I like to think of it. So let U be equal to Y, that's what we said before. We're gonna differentiate both sides. So we're gonna get du over dy, and the differentiation of y is just 1. And if we multiply both sides by d of y, we're gonna get d of u is equal to d of y. So this is the u part, that's the u part right there. Now the d of v, the dv part, is the rest that you have, the rest. This means that d of v is sine of y dy. So v is the integral of sine of y dy. And we talked about this before. This is just going to be the same as negative cos of y plus c. So let's substitute our results into this format. So u times v, u is just y, u is just y. So y times v, v is negative cos y plus c. But in this case, we're just gonna ignore the c. So negative cos of y minus the integral of v. So this is v right here, which is just negative cos of y. And d of u is just d of y. This is gonna be d of y. And we're so close to finishing. I know, it's quite a lot. So this is the same as negative y times cos of y. This is plus the integral of cos of y dy. This is the same as negative y times cos of y plus the antiderivative of cos of y. That's just gonna be sine of y and plus c at the end. So what does this mean? Well, this means that our integral, definite integral, pi over 2, 0, y times sine of y dy, that is the same as the antiderivative, and that's this part right there. So negative y cos of y plus sine of y. And the boundary goes from pi over 2. At the bottom, it is 0. And let's substitute them in together. So we're going to get negative pi over 2 times cos pi over 2 plus sine pi over 2 minus the lower boundary. So this time we got to substitute in a 0. So we get negative 0 cos of 0 plus sine of 0. And we can go ahead and close the bracket right there. Now, if you put these into a calculator, we know that cos of pi over 2 is 0. So this means this whole thing right here is 0. Sine pi over 2 is just 1. And whatever 0 times whatever, it's just going to be 0. So this part is 0. Sine of 0 is also 0. So this is the same as 0 plus 1 minus 0 plus 0. Now, we don't even need to write that. We can just say minus 0 and then close the bracket right there. And this is just going to be 1. This means that after we substitute these numbers into our formula, we're going to get 1. So finally, we have 2 times pi, 3 minus 1 is 2. So the final answer is just 4 times pi unit to the power of 3. So this number right here is the volume of our three-dimensional object.